As a reminder, for a variable to be a potential confounder, it has to be associated with both that independent variable as well as that outcome variable. And in order for a variable to actually confound a relationship, it has to be unequally distributed among the groups that we're comparing. So for example, we talked about that relationship between alcohol consumption and the development of lung cancer. Well, we know that smoking is a potential confounder in that relationship. We know that essentially people who consume alcohol are probably going to be more likely to smoke, and so you're going to have more smokers in that alcohol consuming group. And then in terms of those who develop lung cancer, we know that people who develop lung cancer are more likely to be smokers, and so you're going to get more people who smoke in that lung cancer group. That confounder has to be distributed unequally among the groups that we're comparing. Now, we're going to talk about this later, but if a factor is not unequally distributed among the groups we're comparing, then you can't have the issue of confounding. This is essentially what we're doing with a randomized control trial. We're making sure the distribution of variables that could potentially be confounders, that is going to be equal amongst our treatment as well as our placebo group. And then lastly, a confounder, it cannot be on that causal pathway. It cannot be the direct results of the exposure variable. So if, for example, here, if you have an exposure variable of, let's say, fat consumption, the variable cholesterol level, that would be on this causal pathway because that fat consumption might result in those cholesterol levels. And therefore, because it falls on that pathway, you would not consider that cholesterol level variable to be a potential confounder. So let's look at an example. We are going to, in this hypothetical study, look at the relationship between gender and malaria. And so maybe we hypothesize that male gender is going to increase the likelihood of getting malaria. So we're asking, are malaria cases more likely to be male? What I would do is I would set up my 2x2 table, and I would consider in my exposure group that would be male given my research question, and the unexposed would be female. And I would put my cases up on this column and my controls on this column. And then let's say that this is what the data looked like. I ended up with 88 male cases. I ended up with 62 female cases, 68 males without malaria, and 82 females without malaria. So we set up this 2x2 table, and given that this is a case control study, we would calculate an odds ratio. So when I do that calculation, this is what my data would look like. You might want to pause this video and calculate it for yourself to make sure that you get the same number. So when I plug in the numbers, what I find is that I get an odds ratio of 1.71. I would interpret this by saying cases are 1.7 times as likely to be male compared to the controls. Alternatively, cases are 71% more likely to be male than controls. But I would describe this as a positive association. Now, in the real world, if I was actually looking at this, I would calculate my 95% confidence intervals to determine whether this result I got was statistically significant. Remember that you have to have a statistically significant result in order to determine that that relationship isn't due to chance. So to conclude, is there an association? I would look at that statistical significance. In this case, I do find that I do have a statistically significant result. My confidence interval is on the other side of 1. It does not include 1, which would be the null value. So in this case, I do have a statistically significant association, and so I would conclude that there is a positive association. My odds ratio is 1.71 in terms of gender and disease status for malaria. So it does look like there is this positive association here. I might determine that, yeah, based on my research question, that that it looks like there is a positive relationship between being male and the development of malaria. In this class, I'm not going to have you calculate confidence intervals. I would give these to you, but for this module, I do want you to be able to calculate those measures of association, so an odds ratio or a relative risk. But based on this information, I see that there is an association, and that association looks like it's a positive association. So I might be concerned about the development of malaria in males compared to females. However, I want to pause. And as a researcher, I want to think, okay, I'm looking at this relationship, but could there be some other variable out there that I didn't consider that might be a potential confounder? Could I have issues around bias in my study? In this module, we're focusing on confounding. So do we think that there's some third variable in our data that we've collected that could potentially be a confounder in this relationship? More specifically, I might want to think about the variable working outside as a potential confounder for this relationship. So let's say that I'm looking at this relationship between gender and the development of malaria. I am going to consider working outside as a potential confounder.